The plum pudding model represents one of the earliest attempts to understand the structure of atoms. This revolutionary theory was proposed by J. Thomson, a brilliant British physicist. Thomson's model came at a crucial time in scientific history when scientists were trying to make sense of the newly discovered electron and how it fit into the atomic structure. This model, though eventually proven incorrect, played a vital role in advancing our understanding of matter at the atomic level. To understand why the plum pudding model was proposed, we need to look at the historical context. In 1897, J. Thomson made a groundbreaking discovery, the electron. This was the first subatomic particle ever identified. However, this discovery created a puzzle. Scientists knew that atoms were electrically neutral overall, but now they had found negatively charged particles inside them. The challenge was to explain how these negative electrons existed within neutral atoms. Thomson tackled this problem and introduced his model in 1904 to provide an explanation. Thomson used a clever analogy to describe his model, comparing the atom to a traditional English dessert called plum pudding. Imagine a pudding with plums scattered throughout it. In Thomson's model, the atom is like this dessert. The pudding itself represents a sphere of positive charge that fills the entire volume of the atom. The plums represent the negatively charged electrons, which are embedded throughout this positive sphere. Just as plums are distributed within the pudding, electrons are scattered throughout the positive charge, creating a neutral atom overall. Thomson's plum pudding model was based on 4 key postulates. First, the atom is a uniform sphere of positive charge distributed evenly throughout its volume. Second, electrons are embedded within this positive sphere, scattered like plums in a pudding. Third, the positive and negative charges are equal in magnitude, which balances them out and makes the atom electrically neutral. Fourth, the electrons can vibrate within the positive medium. This last point was particularly important because it helped explain how atoms could emit light at specific wavelengths. The visual representation of the plum pudding model shows a spherical structure. The large sphere represents the positively charged region, often depicted in golden or yellow tones to symbolize the spread-out positive charge. Within this sphere, you can see multiple small blue spheres representing the negatively charged electrons. These electrons are distributed throughout the entire volume of the positive sphere, not concentrated in any particular region. This uniform distribution was a key feature of Thomson's model, suggesting that positive charge was not localized, but spread throughout the entire atom. Despite its initial acceptance, the plum pudding model had serious limitations that eventually led to its replacement. The most significant blow came from Rutherford's gold foil experiment. When Rutherford fired alpha particles at a thin gold foil, some particles bounced straight back, which was completely unexpected if the positive charge was spread out as Thomson suggested. The model also failed to account for the existence of a dense, concentrated nucleus at the center of the atom. Additionally, it could not properly explain the atomic spectra of elements, the specific wavelengths of light that atoms emit or absorb. Due to these failures, the model was replaced by Rutherford's nuclear model in 1911, which proposed that positive charge is concentrated in a tiny, dense nucleus at the center of the atom.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.